I think you'd be hard-pressed to find a workshop without at least one of these. A dead blow mallet. It has a hollow head and it's filled with sand which absorbs the impact, deadening the blow. And just for comparison's sake, this is a soft face mallet. No matter how hard I push down on it while I'm hitting things, it always bounces back. Now I'd like to make a really nice dead blow mallet to use with my milling machine, but instead of filling it with sand, I'm gonna fill it with this, tungsten shot. Now this stuff is weird because it just feels too heavy. It has the same density as gold. So I'm hoping filling the hammer with this stuff means it'll work even better. I've already made a few tools and they all have kind of a similar theme. They have these cool skeletonized handles. I really like the way these look, so I'm going to design my mallet in the same way. This handle was cast in 2 pieces and welded together, and that worked out really well, so that's what I'm going to do with this mallet. So here's the design that I came up with. Now what I need to do is 3D print this so that I can use those 3D prints as patterns to make a sand mold. And from the sand mold, then we can make bronze castings. All right, these things are nice and smooth now and ready to be used to make some molds. You're probably wondering what these things are. They're called gates, and that's actually where the metal is going to flow into the mold. I find that it's just easier to design them into the pattern rather than cutting them out of the sand and risk damaging the mold. This red sand that I'm using is called Petrobond. It's what I always use for my sand castings, and it really is great stuff. It does an awesome job at capturing detail. The metal that I'm going to be using to make these castings is called silicon bronze. Here's an ingot right here. And the reason I use this stuff is because when it's molten, it's really liquid, so it flows into molds really well, and it can also be welded relatively easily. The downside is that this stuff's pretty expensive. This 15-pound ingot was a little over $200. Fortunately, I don't have to cut up this ingot today. I have a bunch of leftover scrap pieces from previous castings. Overall, these castings look really nice with the exception of these areas here. This is called a cold shut. This is where the metal solidified before it could completely fill out the mold. And the reason that happened is really just poor mold design. This is a one-off casting, so if I was going to be making a whole bunch of these, I would redesign how the metal flowed into the mold. But I'm not going to be recasting this. I'm going to use this as an opportunity to practice some TIG welding skills, and I think by the time I'm done repairing this, we won't even be able to tell that there was a problem at all. And to fill these areas, I plan on taking some metal from these pieces here. Also, if you look over here, there's a great big hole, and that's from shrinkage. Metal shrinks a lot when it solidifies, which is why I added these pieces so that the shrinkage occurs here and not in the casting itself. I'm glad I tried fixing these because I think it worked out really well, but it was definitely challenging. TIG welding this bronze is pretty tricky. It's easy to overheat it, which causes it to soften and start drooping, kind of like a candy bar that got too hot. It mostly keeps its shape, but you can tell it got melted. Now what I want to do is clean up the inside faces a little and then darken them with this stuff called liver of sulfur. The inside surfaces are going to darken anyways when I start welding the two halves together, but I want it to look even darker and have a nice uniform color if that's possible. Like I mentioned earlier, welding this bronze is pretty tricky. To avoid overheating it, I just did little stitch welds and then let it cool down before going back and welding some more. Now I need to cast some polyurethane soft faces, but first I need a pattern to create a silicone mold with. And I think the best way to make a pattern is just to turn something on the lathe. I parted off this piece, but I think it's just a little bit too long, so I'm going to shorten it a little bit. That's much better. Now I can move on to making the silicone mold. This part's pretty straightforward. I'm gluing the piece down and building a small mold box around it to hold in the silicone. Unfortunately, this teal-colored silicone never hardened. It was a couple years old, and I didn't think that would be a problem, but it was. So I had to redo everything with different silicone. Same process, but this time it actually worked, and now I have a nice mold. I bought a couple different types of urethane rubber for the mallet faces, and I cast a couple test pieces. This stuff doesn't look all that strong, but hitting it with a hammer proves otherwise. It's hard to tell on camera, but I was hitting it really hard, and you can't even see any marks. This stuff held up really well. And this black one is very rubbery. It might actually be too soft, but we'll just have to see. I thought of a couple different ways to hold the soft faces onto the mallet, but I think this is the simplest. I'm going to cast this modified bolt directly into the polyurethane, and then I'll do the same for the nut. On the other side, I just loosely threaded a nut onto this piece of threaded rod and cast that in place. Then I removed the rod, leaving the nut embedded inside. Now these pieces thread together and it actually looks really good. Well, that's pretty much it. Now all that's left is to clean up the casting a little bit and then fill the cavity with some tungsten shot. This is the tungsten shot that I got, and it's incredibly dense. It has almost the same density as gold. Each one of these is a pound, and this is steel, lead, and tungsten. And look at the difference between the steel and the tungsten. That's wild. This stuff is so dense that it makes the steel just feel like plastic. And what I'm hoping is that because this cavity isn't all that large, this much denser metal should make this hammer work a little bit better. But we're going to try all of these and see which one works the best. I'll start with the steel, and I think I'll fill it up about halfway. That's awesome. All right, let's take it to the anvil. Oh, yeah, it's bouncing back a little bit. Definitely more than I want, so let's try the lead now. Definitely feels heavier. Yeah, that's definitely better. It still bounces, but it's not too bad. So that means that the tungsten is going to work even better. That feels way heavier. Wow. Oh yeah. That's great. It hardly bounces back. Just a tiny bit if I'm kind of not holding it real tight. But if I hold it tight, that's awesome. Perfect. So I'm really glad I bought that tungsten because this would not have worked nearly as well. That's perfect. Well, that about does it for this project. This thing was a ton of work, but it turned out really nice. And I've used it around the shop a few times already, and it works really well. This is something that I'll be able to use for many, many years, and someday I'll be able to pass it down to my children. You may have noticed that I didn't use the softer of the two polyurethane faces that I made. This one is just way too soft and rubbery. I'll hold on to it, and maybe I'll use it someday, but for now, these ones work just fine. If you want to make one of these things yourself, the STL files will be available on my Patreon. And I want to thank all of my patrons for their continued support. You guys are awesome and help keep this channel alive. So thank you very much. Well, thanks for watching, and I'll see you guys in the next video.